Hi everyone, we're here for a Q&A session about race condition, which is a high-scale agentic simulation framework for planning a marathon in Las Vegas that we've built for the developer keynote at Cloud Next. I'm here with Casey West, and I'm Tom Greenaway.
Yeah, so we work together to build the simulation software itself, which is open source, and we've also produced a developer solution. But we thought it might be interesting to have a little bit of a discussion about how it got built, why we built it, some of the considerations that we had to put into it.
Yeah, exactly. I oversaw the front-end development of the project, and Casey took care of the back end and oversaw that.
Maybe this is a good opportunity to introduce ourselves a little bit. Tom, what's your background and what put you in a good position to work on the front end?
Yeah, so before Google, I was an independent game developer. I made many mobile games and have made many games in general in my life. And in Google, I was the web games lead for the Chrome developer relations team. So I've always focused on games in my career, which is great for like a 3D kind of experience like Race Condition.
And my career is mostly about back-end software development, large-scale distributed systems, and architectures. So as we were thinking about building a reference architecture for a large-scale distributed system, and especially an agentic one, my background was good for working on the back-end. So it's always nice to be able to come together with engineers that have different backgrounds, different levels of expertise.
Yeah, absolutely. I'm gonna we have some prepared questions.
We both have Qs and we both have As, hopefully.
Yeah, exactly. Yeah. So I'll ask you, Casey. Tell everyone about Race Condition.
Yeah, so we mentioned a little bit, but Race Condition is our name for the reference architecture that we put together that runs the very real simulation that hopefully you've seen on the developer keynote at Next. It's on YouTube. We can put a link in the description of this video. But the idea was to build a large-scale agentic system, a real one, that could demonstrate a lot of the capabilities of some of our new platform offerings. So Google Cloud, of course, is launching a bunch of products at Next. By the time you see this video, that will have happened.
Yep.
And a large number of those products that we're really focusing on are around what we're calling Gemini Enterprise Agent Platform, which is a collection of platform services, but also open source standards, frameworks, and protocols that we put together to help you build large-scale agentic systems. So we thought, let's build one and show it to you.
Yeah, and you're actually going to be at Cloud Next in the developer keynote with a bunch of other Googlers showing off the demo. And it's pretty cool because it's, on the front end, like on the client, it's this 3D recreation of Las Vegas. Has like the monuments of the Las Vegas Strip, and it connects to this like back-end agentic sort of server system that's communicating with all these different agents. Maybe do you want to tell us a bit more about how that back-end communication works? And actually, I have a question here, which is, what is an agent exactly?
Yeah, great question. So I think at its most basic level, I'll answer that question first because that sets the stage quite well. At its most basic level, an agent, I think, is comprised of three components. So we have a model in our world these days that's usually a large language model for producing some sort of text or generated text. That text could be anything from code to narrative. You have instructions for the model to influence it and tell it what type of job it has, what role it has, what the guidelines are. And then most importantly, I think you have tools, which is the integrations. If you imagine, anyone doing a job, the best way to do that job is to have the right tools for the job. And so the model needs to have good instructions and good tools. You put all those things together and you have an agent. In our case, we wanted to envision what it would look like to build a large-scale architecture and what sort of patterns would emerge when you take something like simulations, which is a pretty tried and true piece of software architecture. Like building simulations is something we've done for decades. But what happens when it's agentic? And in our case, what we learned is that we need ways for the agents to collaborate with one another, discover each other and what their capabilities are. We can coordinate the work and when we have a lot of agents, when we have a lot of sessions, and in our case, we're simulating a marathon with potentially thousands of runners. Managing those communication pathways, especially to the front end, is really difficult. So we had to come up with some new patterns that tend to model enterprise solutions pretty well.
Yeah, because like, and developers will be able to explore the code and the developer solution we've created as well, which showcases how we've got these sort of different demos that use different configurations of agents. And in those demos, they can load it up, and in the 3D front end, they can see Las Vegas, but they can ask an agent backend, like a kind of planner agent, to help them plan a marathon in the city of Las Vegas, taking into account all the different sort of stuff that one would need to take into account when planning a marathon in a city. And that's kind of like what we wanted to recreate or simulate. So yeah, it's come together really, really well. I think it's hopefully it's going to be exciting at the actual show. So I have another question for you, although maybe, well, I'll do my question and you can ask me one.
Sure.
What are some of the AI design patterns that exist that enterprise developers can extract from the simulation?
Yeah. I think one of the big things is how do we get agents to communicate with one another? And one of the things we're working on at Google and in Google Cloud are trying to have standards around those communication patterns. So we have an agent development kit, which is our primary framework for building agents, but then you still need the agents to communicate with one another. We're focused on agent to agent as a protocol, which is essentially a standard that allows agents to advertise their skills and abilities and what they're up to. We use what we call an agent card for that. And then you can use anything from HTTP and HTTP streaming to communicate, but also in our case, we actually used essentially a message bus, which is again, a tried and true enterprise solution, but we use a message bus to pass large numbers of messages with low latency within the system.
Is that with PubSub?
Yes, in this case we used PubSub, and we used Google Cloud Memory Store, which is a managed high scale or high availability Redis solution that we have at Google.
Nice. Okay. Do you want to ask me a question?
Yeah, well, so thinking of design patterns, actually,
Okay.
And your focus on gaming and your career, I'm curious what sort of gaming design patterns that you would want to highlight that we integrated into the system or we thought about using.
Oh, yeah, that's a good question. I mean, there's just like a lot of stuff in the user experience that we tried to have, but there's also in the back end and the client and the back end kind of design, there was the decision of where the authority of the server was the authority of the state of the game was held. So that's always a tricky one with multiplayer games. So in our case, we put the game loop, or the majority of the game loop, and that authority of the state on the server. Obviously, it's not a multiplayer game, but it's a simulation with many agents, so there's some kind of parallels there. So the client is, we could say a dumb client, it's really just sort of listening to what's happening on the server. However, there are certain events which we did decide made more sense in the client. For example, when it's a bit more precise and sort of related to the 3D positions of the objects, like the runners run along the marathon track, and we have these kind of water stations which use a sort of 3D kind of sphere to indicate that they're in this zone. When they collide with that, then it triggers the sort of water refresh, replenishment event, which goes back up to the server, and that effectively communicates, I guess, to an agent that is representing or connecting with the runners, and it just gets a message I have drunk some water, right?
That's right. Yeah. So the back end. In this case, we're using an ADK agent that we called Simulator that runs a simulation. And ADK is our framework where you can have LLM-powered agents, like I described the core of an agent. You've got models, tools, and instructions. But you can also have deterministic workflows as part of that agent architecture. So we use a looping agent to loop through a number of sampling events. So when you think about doing a simulation, you want to take samples of data as the simulation occurs. but that models very closely to what we call like a game loop in games, right? So the server is essentially running simulation and advertising state changes constantly to the front end. But what's nice about the agentic workflow and the idea that you have multiple agents that can all advertise themselves and you can communicate with them independently is that the front end can also send events. What do you call those in gaming?
Oh, like an interrupt or something like that. Yeah, I mean, if it's coming from like a different client to like the main state authority. But the other interesting thing I think to highlight, I guess, and this was something I didn't realize at the beginning when like we started to collaborate on this project and the vision for how the whole agentic backend would work is like, usually in projects you define some very clear API endpoints, right, for the client to be calling to the server. But actually, the way we sort of designed this was to demonstrate how everything can really just be almost like a chat message for the agents to interpret, right?
That's right, yeah. The idea with agents, especially powered by LLMs, is that you don't have to be as rigid as you would be in typical software systems where you have to connect APIs. The APIs are fixed. There are reference points, and we still want to have well-defined APIs in software architectures. But with agents, what we found is, you can ask the planner to run the simulation using natural language. You could also ask it by sending a JSON payload that essentially represents the same thing. What's nice is that either way, the agent will interpret it and generally do the right thing if it has the right instructions.
It's funny, actually, I just looked at my next question, and it's basically what we were just saying, but it adds onto it. How steep is the learning curve to start building with the A2A protocol and the agent registry?
Yeah, it's not too bad. So one of the nice things on Google Cloud Platform, and especially with Gemini Enterprise Agent Platform, is that when you deploy your agents to agent runtime, which is where you'll typically want to deploy and run your agents from, they get automatically integrated into the agent registry, and they get an agent card generated for them. That essentially is the combination of the A2A protocol plus the agent runtime working together. And so the agent registry allows us to have a list of agents that are available within our environment, and any software system could query that agent registry to understand what agents are available, including other agents.
I mean, I haven't actually dived into the agent registry stuff that much, but like, I'm also working on another project at the moment where I'm building some anti-gravity skills, and like the skills kind of need to explain as well, like what they're good at or where they should be used. So I feel like there's a similarity there. Am I right? Or
yeah, I think agent cards actually can expose the agent's skills as part of the standard. So the A to A protocol has that concept, but skills are skills are definitely a new system that everyone is adopting across the board within agentic applications. They're very popular, and it means a lot of different things. This is always the thing in software, is that we use one term and it can mean a lot of different things. So in your case, you're building skills for an AI or an agentic engineering harness like anti-gravity. Claude Code uses skills, Gemini CLI uses skills. And so as a developer, when you're trying to build something with AI or AI assistance, your skills can help guide the model to know how to build the software the way you want it, right? Is that how you're using it?
Yeah. That project will actually be revealed a bit later in the year. So
yeah, but then on the cloud side or on the back-end system side, we're also integrating skills into running agents and autonomous agents.
Yeah.
So those agents can have skills. And a skill is a way to bundle both instructions and tools that can be reused and repurposed across multiple agents.
Cool.
Yeah. So we were speaking of games quite a bit.
Yeah.
And I think something that's really fascinating to me, I'm always looking for the connections or the patterns that get repeated. So, we have this client and server system within gaming, and I'm not a game developer, and I don't game a huge amount, but I see a lot of parallels to business applications that we've been building for the last few years. We have microservices, which are distributed systems. Those are evolving into agents, which are distributed systems because we have multiple agents. They can be deployed independently and integrated with one another. And then client systems, we have things like data bindings and Angular as a framework that can speak to the server, and when it gets state updates, it'll automatically refresh the UI. It feels like it's a lot of parallels to the way games work. The game that I'm most familiar with, the one that I actually do play, is Minecraft, and I know I'm not alone. Very popular game. But it's the same thing. There's a client and a server. There's a tick system or like an update system on the server side. It sounds very similar. What do you think? Do you think that I'm on the right track?
Yeah. I funnily enough, I have not played that much of Minecraft, and I mean, I played it when it first became like it started to become popular, and I bought it like I think the Java version at the beginning. Is that Minecraft Classic now? Is that what it's called?
I don't know what it's called, but I know that that's what I play. I play the Java version.
Yeah, but like I don't actually know a lot about its like architecture, to be honest. But I guess you do run your own server, right? And then your friends can connect to it. So
You can,
Yeah.
yeah.
So probably the server is like the authoritative state, right? And I mean, what's the like? How many users can it handle usually?
That depends. So there are a lot of plugins, and it's a rich ecosystem for Minecraft. So it depends on how much you optimize your server, but you could potentially have hundreds or thousands of connections. There's a lot of nuance there that we probably don't need to get into in this chat. But I do think that it's always interesting to know how like some of the things that we do for fun can influence the decisions we make when we're building like software at work. And so for me, I was able to take some inspiration in the back end architecture from my somewhat limited understanding of how Minecraft works. But how about for you? What sort of games do you play that might have influenced how the simulation played out?
I don't play that many games nowadays myself, but I played lots of games when I was young, and I've got some very specific favorites. But SimCity obviously was a game I played back in the '90s, and when we came up with the idea for this project, I mean it actually took there was a bit of an evolution actually, really, because funnily enough, I think we said earlier that. You're from the Cloud DevRel. I'm actually from a team called Builders DevRel, and now we're working together as teams. And I had worked on, actually at Google, something called Adventure, which was a virtual conference technology we built during the pandemic, and we used it for multiple Google I/Os and other Google events. And that had like full multiplayer with characters, representing people, recreating the physical events, but virtually, and that's how we sort of got involved working together, was because we were actually looking at maybe reusing some of Adventure to do the agentic simulation experience. But then as we got kind of closer to working together, it sort of made more sense to make something new and bespoke. And I remember like there was some initial ideation around like, oh, maybe it could be like a SimCity type experience, like because we understood that simulation was going to be important, and so then we had the city idea. Then I think we changed to an alien space station, if I remember correctly. And then we went back to a city, and someone else added this idea of like, what if we had to plan a marathon in a city? And then we weren't sure like which city to use, and at one point, I don't know if you know this, but like someone was asking me a lot of questions about like how does the marathon in like Paris work, and we were talking about maybe picking Paris because there's obviously quite a few nice monuments there. But then we just realized like, wait a second, we're holding the event in Las Vegas. Las Vegas has the whole Las Vegas Strip with all those monuments. That's a great kind of place to try and do it. So it was just like it's really fun, I think, with projects that have this like creative angle that you just sort of like find your way with them. So
yeah, I think the creative process of putting together like a relatively ambitious, realistic reference architecture and piece of software, especially being able to open source it, is it's a lot of work, and we go through a lot of iterations. So as you mentioned, we probably had half a dozen ideas that we essentially tried to build out as much as possible until we landed on this simulation. But even within this simulation, there are some interesting ideas that some of them made it in and some of them didn't.
It's true.
One of our demos in the developer keynote is around adding memory and the ability to look up, especially unstructured information within your agent architectures. So we were integrating the Las Vegas rules and regulations
Yeah.
in order to understand what you're allowed to do and what you're not allowed to do in Las Vegas, because that can have an impact on how we plan a marathon, whether it be the route or how it might affect traffic or business impact. There was an interesting specific fact about camels that came up.
Yeah, I never actually looked into the legislation or and that thing, but like I know that at some point we started to talk about putting like a 3D camel into the world as like one of the runners.
Yeah, I can give you a little insight,
yeah,
which
yeah,
is
totally.
one of the laws on the books in Las Vegas is that you are not allowed to have a camel on the road.
Okay.
Like specifically a camel for some reason. And so, of course, that got us very interested in camels, and we really wanted to put a camel on the road.
Okay. Yeah. And then we were like, maybe it could just be a camel emoji at one point. Yeah.
Yeah.
So we yeah.
So what happened with the camel?
I don't remember exactly. I think that part of the demos just ended up like we ran out of time, right? Like
Yeah.
we had to reprioritize, which is sad because REP camel. Okay, well let me see what else I've got here. Oh yeah, which parts of the game are truly agentic? Like what parts have agentic brains?
Yeah, so almost all of the agents in the system have an LLM or a model as a brain, but that we had to make some compromises because a number of reasons. One of them is that doing demonstrations during a 1-hour developer keynote is a bit of a contrived experience in that you have a very limited amount of time. So many of us have probably seen cooking shows where you prepare a meal to be baked or to be put in an oven. And then it's going to take hours potentially in the oven. So, Julia Child was famous for this. She'd put something in the oven and then say, this has to bake for an hour, but here, I'll pull this one out that I've just completed out of another oven, and here you go, here it is, right? And so we do the same thing a lot in the demos, but essentially time gets really sped up. So simulations historically could potentially run for hours or days or even longer because you want as much information as possible, or because you're modeling what would be called like an NP-hard problem, or a problem that essentially is an optimization problem where at some point you have to cut off the amount of time you compute, and you just have to take the best information you have at that time to make a decision. I say all of that to say we have planner agents that are planning a marathon and planning its impact on the city, understanding traffic assessments, that sort of thing. We have simulator agents. Those also have LLM brains, although some pieces of the simulation are essentially very deterministic. For example, we talked about the game loop. So when we actually execute the simulation, we essentially want to control time and take a number of samplings over an amount of time that represents the total duration of a marathon, which is usually around 6 hours for most marathons. Sometimes it can be more, sometimes less, but about 6 hours. And so that's what we modeled as well. But I think the real interesting thing is where the scale and complexity starts to play in with a simulation like this. The runners themselves, we wanted to be agentic.
Yeah.
So the runners are agents in that we use ADK, we use the agent development kit. They speak the A2A protocol, just like all the other agents in the system. However, our first implementation of the runners, in order to get the scale we wanted, actually removed the LLM from the equation. So they were deterministic. And you can think of that sort of like your classic API. They took a JSON, well-structured piece of input, they manipulated their state, and then they reported their new state back out. That allowed us to get sub-second response times out of the agents, and then we could have thousands of them running. So when we have a tick rate of every 5 seconds we take a sample, or every 10 seconds we take a sample, we can have 1,000 or even 10,000 runners responding within that amount of time, so that we can collect our data effectively. Because as you know from game development, and I have learned, is if the tick rates start to slow down, that's what we would call lag. And those of you who play Minecraft know how problematic lag is on that game. And so we didn't want lag. But we also have a version of the runners that is powered by a model. This is something that I think is work that's close to you as well, which is we wanted a model that we could do a large number of calls on, but the runners aren't necessarily the most intelligent models out there. They basically have to turn their brains off for the most part and make very minimal decisions, right? But we still want to represent or understand like what a little bit of chaos and non-determinism would be in a simulation environment. So we want the runners to be able to make decisions we wouldn't necessarily expect. So we wanted to use a model.
Yeah.
And so we ended up with an open source, open weight model, which I think you have some experience with.
Yeah. So, and my understanding is like we're running that, like the scale part of that is we're using Google Kubernetes engine, and we're basically scaling up these Gemma 4 open weight models. And I have a question as well for that, but I'll come back to it, I guess. You're right. I have been playing around with Gemma quite a bit lately. There was another project I was working on, which is almost like a spiritual successor, I guess, to Adventure. I've called it AI Venture, but it's actually like a little single player kind of vibe coding puzzle game journey experience. But I wanted to demonstrate how Gemma 4 is able to do like really good vibe coding, kind of like code generation locally in that demo. And also there's actually a little puzzle. I don't know if you saw this one, but there's like one that's more like an agentic robot that actually like you give it some instructions and it tries to like execute over and over again whatever you tell it. So I have been playing with Gemma 4 lately. I was curious, like with the simulation in race condition, what's sort of like the ratio of runners to Gemma 4 model, like instances?
Yeah, so a lot of that is not super easy to calculate because we run Gemma 4 on an auto-scaling cluster, a Kubernetes cluster, or GKE. And we're running it using VLLM, which would be the primary serving mechanism for a model these days, especially on GPUs or TPUs. So we use VLLM, and really the scaling for the model itself is about how much concurrency and token throughput you can get. So it's not so much about how many agents you're running or agent sessions you're running. It's more about how many tokens do you need to get out and how many simultaneous calls do you need to make. So that calculation is honestly a little bit challenging. So in our case, it's about, I think it's around 100 runner sessions to one GPU or one VLLM and Gemma 4 instance.
This might be a silly question, but like, I mean, I guess depending on what's happening in the simulation, it would go up and down how many like tokens it needs. So is the idea that GKE can like dynamically scale that appropriately?
That's right. So GKE has really good auto scaling characteristics, and you can configure that at the infrastructure level based on parameters you choose. So it doesn't scale indefinitely. It has limits that you define. And that's really helpful. But Gemma 4 is actually an ideal model for this scenario because, while we have Gemini, which has the full, it's a large language model, fully served and managed by Google, has access to the world's information. We don't actually need all of that. We don't need all that power, and we don't need all that knowledge for the runners to make decisions about whether they drink water or how motivated they are when the crowd cheers for them. So Gemma 4 has the right amount of inference capabilities, the right amount of knowledge baked into it. And it's also the case that we're going to make thousands of requests to the model within a minute or two to run the simulation. So the real question becomes, how can we get that throughput in a cost-effective manner? And while GPUs can be a bit pricey, getting guaranteed throughput on a fully powered model like Gemini is also pricey. So we wanted to make sure that we get the best of both worlds, or we try and find the compromise that we need.
Yeah, I mean, and it's not just around price, but like different companies and different enterprises might need to they may have some reasons that they need to use Gemma versus Gemini. Actually.
Another big thing is fine tuning, and so we can also fine tune Gemma to be essentially an expert at running marathons, right? So that it can make smart decisions, and that's another way to use private inference to your advantage. Yeah.
Next year we'll have like actual robots running in Las Vegas. We'll go full simulation. Yeah.
Every year has to be a little bit bigger and more ambitious than the next.
It says, I can make the front end look great. Oh, thank you. But how do you sleep at night, Casey, knowing that these autonomous agents have access to enterprise tools and databases? What happens if they hallucinate or get hit with a prompt injection?
Right, so the security and autonomy questions will always be there. And as someone who builds agentic systems for a living and helps other teams build agents at large-scale companies, I think that this is an ever-present concern, and it's a realistic one. Agents have access to only what you give them access to, and that means a couple of things. We like to consider this in Google Cloud a shared responsibility model around security. So we're trying to build a platform that allows you to secure your agents well, but you also have to write secure agents. So it's a little bit of a give and take. In our case, we have built within Gemini Enterprise Agent Platform a series of capabilities that I think are very important. One of them is agent identity. Those of you who build a lot on Google Cloud will know, everything has an identity, and identity-aware network connections are an important part of the design patterns for building on Google Cloud. And so we built that into our agent platform as well. So we have agent identity. Every agent gets a unique identity. And that means that you can understand like who or what principal, what service is making requests. So then you can protect the systems that the agents are interacting with Agent Gateway. So this is a network layer security protocol that allows you to define who or what agents or services can make requests to your API and protect it. In our case, you have things like MCP servers, Model Context Protocol, which is a way to bundle tools and prompts and skills into a network attached service, so distributed systems like we've been talking about. And you can provide security for that. You can say, our planner agent only has access to read financial information, but even though our MCP server has tools to modify our budget, the planner agent isn't actually allowed to modify the budget. So you can control that at the network layer.
Yeah.
So,
and one of the demos focused on that.
That's right.
Yeah.
That's right. So you have control as the agent creator to determine what tools your agent has access to. But as we have more of a mesh system with agent registry and tools registry in our agent platform, we need to make sure that we're also integrating security policies at the network layer to keep things safe.
Okay, I'm gonna change track and ask you, what was the first software product you made?
Oh my, what was? So my career started in large part in open source. My first job was at an internet service provider back when dial-up was a thing. You probably don't remember that.
Actually, I worked at an internet service provider when I was younger, and they still had dial-up.
Yeah.
It's like in regional Australia, which is where I'm not from the region of regional Australia, but I'm from Australia. But in regional Australia, they still needed dial-up.
Absolutely.
Yeah.
And I grew up in Western Pennsylvania in the United States, which was still somewhat remote in the late 90s, early 2000s. So I worked at an internet service provider. And at that time, the language that was really building the interactive web was Perl. So I got involved in the Perl open source community very early in my career. And so a lot of my first software that I actually published or that I'd be able to really talk about were what we called CPAN modules, which is like the libraries of Perl.
Okay. Is there a lot of your Perl code running on systems in the world?
Yeah, this is my fun tiny flex, which is Perl is distributed with many operating systems on many systems automatically, and I have made very small contributions to the Perl core, so I'm a Perl maintainer.
Oh, wow.
But what that means is, for example, every Apple computer that gets distributed has my name and email address on it because it includes some of my software.
Okay, scary.
It's by no means award-winning work, though, and you have some of that.
Yeah, I've made some games that have like won game design awards and that kind of thing. Those were more before like Google, so so like Duet was like the most popular game that I made for primarily like iPhone and Android sort of app stores.
Cool.
So yeah.
If I wanted to play Duet, like what would be the scenario where I'd get really into it? Would I be like on an airplane trying to pass the time, or is it like a truly immersive experience, or both?
It's kind of a bit of both. That's a really good question. So Duet, they're very bite-sized like little levels. It is a very brutally difficult game. And that was sort of intentional. We wanted it to be something that like, you fail quickly. It's very clear. Like, there's no like health system. It's like you hit one of the obstacles, you fail, it automatically rewinds and just immediately starts again. Like that level. So it sort of builds up this frustration. But then that means when you do get through a level, it like you just get a lot of euphoria. And we worked with a musician that had never worked on a game before. His name was Tim Scheel, and he did the soundtrack. So actually, I do recommend people play with headphones because it's just like really, really great, beautiful sort of minimalist music. Which another little claim to fame is the Queensland Symphony Orchestra of Australia performed it, and Tim was like a conductor, where we did this like big kind of show of Duet back in my hometown of Melbourne. So
that's very cool.
Yeah, it was cool.
Okay, so I want to ask a question about that experience. So game design is very intentional, and trying to sort of invoke emotion or an experience for the user is very intentional in game design. So I'm curious how that is translated to you being a developer advocate at Google, and like what do you do to get developers excited about the products that you're working on or the things that you're involved with?
Yeah, interesting. I mean, and it's kind of funny because sometimes I don't know how to explain like what I do to people that I meet, like especially non-technical people. But I guess like I approach it as like trying to make inspirational demos, and often my demos end up having some gaming element to them, or they're gamified in some way. So I think like what you want to do is you want to take the technology and see what kinds of things it can unlock in the field, say in games, that weren't possible before, right? And like lately in the last couple of years, I've been really focused on AI in games in particular, right? Obviously, everyone's focusing on AI. But I don't, I mean, as a game developer, especially as like someone who's, really handcrafted games in the past, I don't want it to just be about like, oh, now we can just generate all the art or all the, music and audio of the games. I mean, maybe there's ways that could be used in an interesting way if it's like maybe using some of the input from the user, for example, so that you're doing something that wasn't really possible before. But what I actually think is the most interesting part about these new AI technologies in games is really just thinking about game mechanics in the gameplay that weren't possible before that now AI can unlock. So like, I talked about the NPC that you bump into in the AI venture demo that I've done recently, and you give it like a prompt, and then it basically keeps executing that prompt to complete the task. And so that demonstrates like the tool calling, but it also just in games that's a really interesting kind of new space that obviously some of that could be sort of done in the past with AI in games, but I just think there's a lot of new like emergent gameplay that can be explored. So I think there's still tons of space for like crafting, unique artistic ideas and experiences in games, coupled with all this new technology.
I think that's great. One of the hard parts being on the back end systems and the cloud systems, which is where I tend to live, is getting people to understand the solutions that we make. They're difficult to visualize, they're difficult to see and understand, but building the simulation to try and expose agentic solutions that are powered by Google Cloud Platform made it real. Like it makes it like a visceral experience. It feels like a game, even though I think technically we wouldn't call it a game, right?
It's like game-like, yeah. It's sort of a sandbox experience.
Yeah, but I think it's really good to partner up, and that's something that I think we did really well with the team of people that we had working with us, which was to take experts at front-end systems, visualizations, user interaction, in order to expose and demonstrate back-end systems in a way that felt visceral, I suppose.
Yeah, and I mean, like you said, we worked with like a lot of other people. There were 3D modelers that did like the cityscape of Las Vegas and stuff. So it's not like we used AI to generate the city, for example. What else? Oh, this is actually an important thing to mention. So if a developer forks the race condition repository today, we're giving away some like free Google Cloud credits with it. What is the very first thing you hope they try to modify or break when they do that?
I think the runners are very interesting, especially with Gemma 4 as a brain. Again, they're not big agents. They don't do a lot. They don't think a lot. But one of the things we added with Gemma 4 to power the runners is the ability for them to have internal thoughts.
Yeah.
And I don't know how many of you out there have run a marathon. I've not tried, and because I'm terrified because it sounds very hard.
There are a couple of people on the wider team though that have. They've told us some
and when they talk about the inner thoughts that the agent or that they have on a race, some of them we can't expose in the developer keynote. But I think it would be
I hope we don't. Yeah.
I think it would be really fascinating to see what else people could model on that scale. So I think when it comes to a simulation like this, the runners are kind of like end users or testers for the simulation itself. The plan for the simulation is generated using AI, and we want to test how good that plan is by executing the simulation. The real test is whether or not the runners enjoyed themselves, they had a good experience. But I think it'd be really interesting to continue to expand that to maybe model local businesses. How are they impacted? If you have a drive-through fast food chain and your road is closed because of the marathon going by, that might have a dramatically different impact than a coffee shop that you can just walk into, for example.
Sure, yeah.
And I think it'd be interesting to add additional agents into the mix that might be affected by the existence of a large-scale event like that in the system.
Yeah, I mean, another one that pops into my mind is that I remember early on we were thinking about making it that like the runners could actually just run off the track if they wanted. And like we imagined, what if we allowed it so like the runner can have their own thought of like, hey, I'm going to try and cheat, and like go down a side street or something.
I was really excited about that too. I think continuing down this theme, continuing to expand the runner capabilities of the runner's like sort of internal thoughts. You can give it a persona, maybe a goal. Like maybe some runners think of the marathon as a zero-sum game where they need to win and everyone else needs to lose, and maybe whatever it takes. So that cheating would be interesting.
New function tool calling for like trip up other people. Yeah, we did talk about it having tripping and like people bumping into each other.
Yeah, and we do try and anticipate things like traffic concerns, but I think it'd also be interesting to see what happens when that goes off the rails. Public safety goes hand in hand with like traffic issues. So what happens if you don't have enough public safety officers and maybe cars try and sneak through the marathon route? That could disrupt the runners, maybe catastrophically.
Could go wrong.
Thankfully, it's just a simulation.
Yeah, for now. Yeah. Okay, wait. I have another one about traditional apps hit infrastructure bottlenecks, but with agents, we hit token bottlenecks.
We do.
When context windows overflow.
Yeah.
How do you manage the token scale?
Yeah, everyone is rightly concerned about the amount of money you might spend by the amount of tokens that you'd consume. And that's one of the reasons why we powered the LLM-based runners with private inference, is that we can hit that as much as possible. We can saturate the infrastructure that we can afford to spin up without adding additional cost beyond the infrastructure. So that is an issue. But within agent design, there are a couple of techniques that are really important. One of them, or I would say they all fall under the umbrella of context management. So the amount of context you send in to a model determines how expensive it's going to be to read it all and then ultimately provide a response. Typical agentic solutions build or accumulate context over time. We know this when we interact with Gemini and we have a long conversation. What you might not know is that every time you hit enter on your response back to the model, what's happening in the environment is that it's bundling your entire session history into one large context and then sending that every time. So every interaction with Gemini, the API or the large language model, is stateless. So in order for Gemini to know what you've been talking about, it has to send that history to Gemini every time. So that accumulates over and over again, and every message gets a little bit more expensive. So within context management, there's a couple of things we can do. One of them is that we can have sub-agents, which is why this is a multi-agent system. So a sub-agent might have a very specific task. It only needs a small amount of information to achieve that task. For example, the runner doesn't have to know anything about planning a marathon. It only needs to know about its current environment in the marathon at the time that we invoke it. So we control context by eliminating history and not adding any additional unneeded information. That keeps it a very small set of tokens, which is very inexpensive. The other thing we can do are things like compacting the history. So that does mean that you might lose some fidelity, some details that you've accumulated over time, but it also means that you cut down on the overall token size. So I think those are important things for people who might not build agents every day to sort of recognize. And we're all actually using those techniques all the time when we interface with, say, gemini.google.com.
Yeah, yeah. No, it's really cool. I mean, I think the other thing with this whole deployable architecture is how we're calling it, is it gives especially enterprise developers all these different kind of AI-driven design patterns that they can borrow ideas from or like learn from. So that sounds like an important kind of design pattern is like dealing with that kind of token context.
Yeah, and the more context you accumulate, the longer it takes for an agent to respond. And so that can be quite frustrating as an end user. And I think when we're building an interactive experience
loop as well,
like this simulation, users don't want to wait around for several minutes to find out what happened in the simulation. So we try to have very real-time information being presented. So one of the other design patterns that we incorporated, which we lifted from common classic enterprise software design patterns, is a message bus. So we have this pub-sub system where we can emit messages from all of the agents to pub-sub as a broadcast, and the client can actually read that. So the visualization that you see when you look at the simulation, or we showed in the developer keynote, is getting real-time information about the inner workings of all of the agents, and we designed that so that we can give you that visibility.
Yeah, because like it has its own connection to the pub sub directly from the client.
That's right. Yeah. There's a gateway system in place, but basically it's a direct fire hose of information from all of the agents about their life cycle as they're trying to deal with things. So you don't just have to wait 2 minutes for a simulation to finish. You can actually see what's happening every tick. You can see what happens every time a runner gets an update. And I think that's really fascinating pattern as well.
Cool. All right. One last question for me. Are you planning to go bouldering in Paris?
Yeah, so I love rock climbing. It's one of my primary sort of activities. And I always travel with climbing shoes and a chalk bag. It's a very lightweight set of things to be able to go. My preference, if I had more time, I'm here for a short amount of time because we're very busy leading up to Google Cloud Next. My preference would be to go to Fontainebleau and go bouldering in the woods or in the forest. But in lieu of that, Paris has many really excellent indoor climbing gyms, and so I will visit one of those on the weekend.
Some of them have like beer as well, I think, in them.
Oh, yeah. Climbing is a whole community activity. It's very collaborative, and that's something I love about it. I've been all over the world to climbing gyms, and even when I don't speak the same language as the people around me, we're always rooting each other on, and in Paris, we'll be saying "Allez, allez."
But you're going to be on stage at Cloud Next, so stay safe. We don't want like the understage to have to jump in.
Although if they did, they would be amazing.
Yeah, of course. But Casey, thanks a lot for this chat. I hope people explore the code and the developer solution we've made. Watch the developer solution video, explore the demos that we've got. There's the whole developer keynote itself will obviously be put online as well. They can watch that too. Thanks again for coming and having this chat.
Yeah, thank you. I think one of the beautiful things is taking everything from Angular and game development all the way to low-level back-end system architectures and Kubernetes clusters and putting it all together in one great example.
Yeah, it's been great.
Cool.